Greetings and welcome, ladies and gentlemen, boys and girls. Today, we're going to graph things you never thought existed. Imagine a line, and then on that line, another line that intersects it that does not exist because it's imaginary. But I guess we were imagining the first line too, which was real, which is now making this theory a little bit harder to understand. But we're going to graph things on the complex plane. That's right, we're going to be able to graph imaginary numbers. Have you ever wanted to know where an imaginary number lived? Today we'll find out. So a complex plane is a coordinate system that has a real axis and an imaginary axis. They both actually do exist. It's called imaginary because of imaginary numbers, blah, blah, blah. So here's my real axis. It's like the horizontal. And the imaginary axis is where the y-axis would have been, except we imagined it to be something different. And a couple of things to know about this is that we can plot points on this coordinate system. And in fact, usually these points are referred to as like z's. So z1, if I wanted to plot the point like, for instance, like 2 minus I, where would that be? That would be over 2 on the real axis and down 1 on the imaginary axis. So here's the point 2 minus I right there. 2 minus I. That's a terrible I. There we go. Right there. So there's 2 minus I. If I had like z2, let's say I've got a cool point like, I don't know, how about 0 plus 3I? All right, so this is a pure imaginary number, so it would make sense that a pure imaginary number would exist solely on the imaginary axis, right? So I went left and right 0 units and then up 3 units. So here's 3I right there. Good stuff, good stuff. So this is a rectangular representation of the complex plane, but we can still like do different things with this. You can actually find the absolute value, which the absolute value, you might recall, is the distance a point is from 0, right? That's the proper definition of absolute value. And so if I want to know the distance that one of these imaginary points are from 0, it would be measured this way, right? Just the distance from the origin to that point. This distance, for instance, the absolute value would be 3, something like that. So let's talk about absolute value of a complex number and what that would look like. Coming at ya. Here we go. Scrolling down. Here we are. Absolute value of a complex number. Guys, you need to just fall in love with the Pythagorean theorem because it is just coming back to haunt you every day of this course, it seems. It just don't disappear. It just don't go away. So notice if z is equal to a plus bi, then the magnitude of z, or the absolute value of z, I guess, yeah, I wouldn't refer to that as magnitude. It's not a vector. Would be the square root of a squared plus b squared. Which notice that makes sense. If this is my A, this is my B, it's a little right triangle. To find the absolute value or the distance from 0, this is just Pythagorean theorem. A squared plus B squared equals C squared, or in this case it would be the absolute value of Z would be this hypotenuse, like so. Right? So that's good stuff. And it turns out another name for the absolute value of a complex number, at least if I'm perceiving this in a polar coordinate system, would be to refer to that as the modulus, all right, which I think I had written down up here. The modulus is the distance from the origin to a complex number, and it's represented by r, which is kind of like radius, right, r theta. That's going to be for the polar coordinate system of the complex plane, whatever. An amplitude or argument, both names are legitimate, will refer to the angle to that point. So if I, for instance, have, so this would be r and this would be my theta, or amplitude to that point. But we'll get to that in just a moment. So let's let's graph. Well, I've already graphed some. Well, yeah, let's do one more. Just why not? Why not? For funsies, for old time's sake. I mean, how many examples does an old teacher like me still have left in him anyway? I mean, you know, this is like, these examples are gold. Just gold. So graph each number in the complex plane and find its absolute value. And here I've got z equals 3 plus 2i. So if I want to graph this, a is equal to 3, b is equal to 2. So I go over 3 units, up 2 units, and this would be where the point is. I think you agree, right? So imaginary axis is the vertical one. So a equals 3, b equals 2. If I want to find the magnitude of z, I keep saying magnitude, I apologize there. Absolute value of z, that'd be the square root of 3 squared plus 2 squared. And man, you guys could just do Pythagorean theorem for days. For days. So that's the square root of 13. Like so. And what that's claiming is that the distance, that this point is from the origin, right? That's the definition of absolute value. Right? Absolute value of z is the square root of 13. Right? That's what that distance would be. Which, by the way, is a little bit more than 3, a little bit less than 4. Square root of 16 is 4, square root of 9 is 3, somewhere in the middle. Maybe it's like 3.5, something like that. And you could see that the horizontal, this was the 3 and this was the 2. Technically, if you didn't even memorize that formula, you would be still fine and dandy because you guys are expert Pythagoreans. So, how about this? This is interesting. What if I wanted to represent a complex number in polar form? Oh. And this is also referred to as trigonometric form. So the polar form of a trigonometric form of a complex number a plus bi is r times cos theta plus I sine theta. Or I like this little shorthand version they've got. This is like short version. It does look like it says like racist, but maybe only to racist people would it look like that.
What is CIS?
CIS is just the abbreviation for cosine, I, and sine. And they just like ignored the rest of this and the fact that there was another theta in there. So it's just like mathematicians, like if you were trying to text your friends a complex number, you know, it was like part imaginary, and they wanted it in polar form, and you didn't want to text out this whole thing, like this is how you do it. Like you're just like, you know, 3 CIS pi over 4, and then like they're like LOL, and that's what they would do. So I mean, really, I mean, mathematicians pretty much invented shorthand. I'm probably lying about that.
I don't think it makes sense. I feel like that.
It does, yeah. It's you have to know the shorthand to be able to do that. Yes, so you got to know what's up. Yeah. Yeah. Good stuff. Good stuff. So and then one of the ways that you could, we'll come back to that in a moment. One of the ways that you could find the amplitude, this stuff is just like so familiar to you. Amplitude or argument of a complex number. If you wanted to find out what theta was and you knew what your A's and your B's were, yeah, you could figure it out like that. And technically the book had a different version of this, which is similar to when we were talking about you know, all the other crazy stuff about polar form of a point. But so you do have to be careful of which quadrant it's in and reference angles and stuff like that. So that's all good. All good. RCIS theta. So let's do an example. And let's take a gander at this, shall we? So if I want to express the following in polar form, let's see what I know. I know that A is equal to -3. I know that B is equal to 4. And I've got a couple things I can do. I've got to figure out R and theta. To find R, all right, which is the modulus, which is such a cool word. Sounds like it'd be a character in the Matrix. That's just going to be R equals A squared plus B squared, right? Because the modulus is the same as the absolute value of Z. And the theta would be tan theta equals B over A. So using like these two, I'm going to find out what R and theta are. That was somewhat symmetric of a sentence. And then just plug it straight up into this form here is what I'm going to do. So to express in polar form, I merely plug and chug. R is equal to the square root of -3 all squared plus 4 squared. So R is equal to the square root of, that's 9 plus 16. Wait a minute. Guys, this is going to be a Pythagorean triple. R equals square root of 25. R is 5. You don't say. And let's see. Tan of theta would have equaled 4 over -3. So then we would tan inverse both sides, right? Oh, yeah. Tan verse. And we'd get theta equals. Now, tan inverse, actually we'll get the reference angle technically equals. What is the old tan inverse of that? Of 4/3 or -4/3. The reference angle, the positive version, is 53.1301 degrees. I'm still in degree mode there. And if I wanted to find theta, I've got to ask the question, which quadrant was I in? Well, it was -3, 4, so back 3, up 4. That's second quadrant. So to figure out theta, I would just do 180 minus this. Right, so I'll get theta equals. Uh-oh, sniffles coming back. Oh no! 126.8699 degrees. And if I wanted to convert that to radians, I could just multiply by pi over 180. Or I could have just been working with radians from the get-go and just done pi minus alpha. So what is the polar form? Guys, this is weird. Did this make you think about the movie Polar Express?
What was that?
I've never seen the movie,
Yeah.
but there you go. I just thought that was kind of weird.
So are you going to do that as a
Make CG movies? No. Although, maybe I've dabbled in that before.
But he's not going to be using math for his next.
So,
Yeah, there's a right there.
so let's see.
Or is it you like operate?
5 times the cosine.
There's no steam.
No, I'm just saying. I'm just like wondering.
You can run a rail right off the tracks train thing. Yeah. You gotta be careful with that. Plus I times the sine of I ran out of room, theta. You know what's up.
That's the arc of
So this is the polar form.
Oh.
Or yeah, I could have expressed it as, and man, wouldn't it be great if I had a shorthand notation for this? Yes, because then I would have fit it. It would have been 5 CIS 126.87 degrees.
Why don't you replace the sine?
Yeah, why don't you replace the theta with?
Yeah, why don't
Was it just because you ran out of room?
I ran out of room.
But it should go.
Oh yeah, yeah. It would definitely go there. Like if this was like a real lesson on how to do math, that would be there for sure. And also, I would have left enough room for me to fit like a graph, but I'm like, like I can't, like I'm stuck. So
It's not a real math
Guess he's
teacher
not
anymore.
going out on this beat.
yeah, so let's see, 5 and 126 degrees. Tell you what, here's a handy dandy graph for you. Watch how cute and adorable this will be. There we go. This is amazing. Oh wait, I can't see the. There it is. There. So 126 degrees would have been like flung around something like this ish. Who knows? There's 135. Yeah, something like that. And I'd go out 5 units. So this would be the location of that point. Right, something like that. And still, this is I, the imaginary axis, and then X is the real axis, sort of thing. Even though it's expressed in a polar representation, is how that would work. So there you go. And notice also the relationship between that and rectangular form of going left 3 and up 4 takes me to the same spot. Same spot. So let's keep going here. Here we go. I like it. I like it a lot. Oh wow, thing of beauty. Yeah, one more example and we're done. It's like we're retiring this lesson. It's like this lesson is resigning itself onto like the Florida of YouTube, and it'll just be there until it dies.
So what is the lesson going to go on to do after this?
So you're moving to
Is
Florida?
it not at liberty to say?
Maybe it's not for it to share. I don't know. Maybe it's not its thing, you know. So let's see. It says graph, then express in rectangular form. Hey guys, does this make you think about the movie Rectangular Express? Oh, that's not a thing. I'm sorry. I don't know what I'm talking about. What do I know from this? I know R is what and theta is what. R is 4.
Got it there.
That's the other one. The one that means
Guys,
painful.
have you ever written 11 pi over 6? And then like when you're like writing 11 pi, you just want to like go straight up and like write macro pi? Have you ever thought of that? Like what's the Guinness Book of World Record for like the world's largest pi? Like this is like almost like a music note equivalent of like where you just like throw like more things across the top and it's good apparently. That's how music gets better, I believe. But I don't know, it just makes me think about like, that's a lot of pi.
It's actually a roller coaster.
I see the roller coaster, I do. Yeah, there you go. But yeah, every time I write 11 pi, that's what I think. Never mind 111 pi. I would just be like, whoa.
That's like a really good feeling.
Yeah. So that's my R, that's my thetas. 11 pi over 6, where is that? Which quadrant would that be in?
4.
Quadrant 4, I think I agree with you, sir. You could just write that.
Little boxes.
Are you certain that it's in quadrant 4, or do you want to just like maybe write that on a piece of paper, put it in an envelope, tape it to the ceiling, or maybe the roof, and we'll find out whether you're right or wrong later. So here we go. 11 pi over 6 is the same as a negative 30 degree angle. In case you didn't know. I don't know, that's like, 330 degrees. Pi over 6 is 30 degrees, and then like 11 of them. Yeah, it's like that. So there we go. We've got like all the way wrapped around like this, and it is 4 units out, so 4 units. Right like that. Here's my imaginary number currently in polar form. How do I get it back in rectangular form? I'll show you. because I'm a teacher presently, right now, at this moment. Which actually, I suppose I'd still have my license to teach. I think that's good for like 7 years in Vermont, which is pretty nice. 4 times cosine 11 pi over 6. What is the reference angle of 11 pi over 6? This would be 1 pi over 6, which I guess you can make like a kind of big pi out of that. So 1 pi over 6 is the reference angle. And is cosine positive or negative in that quadrant? Positive, so that's the cosine of pi over 6. And is sine positive or negative in that quadrant? Negative in that quadrant, so that's the same as negative sine of pi over 6 if I referentially am doing this. What is cosine of pi over 6? Hand trick it, root 3 over 2. This is now minus. Sine of pi over 6 is a half I. So to convert this to rectangular form, all I'm doing is going through and like evaluating this stuff. And then I'm going to distribute the 4. And I'll get 2 roots of 3 minus 2I. And what is that claiming? That is claiming that if I go over 2 roots of 3 units, oh, I got confused at the arrowhead there, and down 2, oh, that actually even looks like 2 right there, that would land me at the same location, and this is now rectangular form like that. Thanks for hanging out, friends. Have a great day. Bye-bye. Guys,